We are going to make a mapping diagram using this relation. Now, a relation is a set of points or ordered pairs. You have your first numbers in the ordered pair, which has to do what's called the domain, the x values. You have your second number in the ordered pair, which has to do with your range, also known as the y values. Now, domain can also be called input. Range can also be called output. So it really all depends on what math teacher you have. But this is how I make a mapping diagram. You make two bubbles. Or in my case, they're terrible blobs because I don't know how to draw. But you make two bubbles. You take the numbers in the domain and you list them in order. Now, it looks like already that this is listed in order, so life is good. -7, -3, -2, 4, and 6. Okay, now what I didn't do is I didn't label this first bubble. I'm going to label it domain. You're going to have other teachers that might label this input, but I'm going to stick with domain because that's more Algebra 1, whereas input is more like 8th grade math. It all depends. Okay, now in the second bubble, I'm going to write these out in order too. Now you notice they're not in order. 1, 0, -1, 7, and 4 are not in order. So my smallest number here is -1, then 0, then regular 1, then 4, then 7. Now, if at any point, if these numbers repeat, like if I had like a -7 in the domain and a -7 somewhere floating around in the domain, you're not going to write it out twice, okay? Now, this second bubble, range, all right? Some teachers will put output, whatever. -7. Now, what we're going to do is we need to map these. In other words, what's happening with -7? Well, -7 is going to 1, so I'm going to take -7 and put an arrow to regular 1. -3 maps to 0, so I'm going to put -3 to 0, like so. -2 maps to -1, so I'm going to put -2 mapping to -1, like so. 4 maps to 7, like that. 6 maps to 4, like that. And we have ourselves a mapping diagram. Again, depending on the teacher, but depending on the book. I made bubbles. Some teachers use rectangles. I called it domain and range. Some teachers use input, output. But either way, you're taking the x values, you're pointing to the y values, and you're making sure everything is in order. Okay? That's a mapping diagram. Hope this helps. My job is to graph this relation. Now, a relation is a group of ordered pairs or a set of ordered pairs. My job is to graph these. So I'm going to graph these on a coordinate plane. Now, let's, before we graph, kind of review what a point when graphed looks like. A point is given to you as an x and then a y. For example, you would be my x, you would be my y. If the x value is positive, you go right. If the x value is negative, you go left. If the y value, so in this case 7, 1, -7, so on and so forth, if the y value is positive, you go up, and if it's negative, you go down. So I have 5 points that I'm going to graph, and I'm going to use different colors to graph them. -2, 7 means I'm going to go left 2 spaces, then up 7 spaces. So left, I start out at 0, 0, also known as my origin, and I'm going to go left 1, 2, and then up 1, 2, 3, 4, 5, 6, 7. I put a dot there, and that is my coordinate, -2, 7. For 0, 1, notice that I have 0. So am I going to go left? Am I going to go right? No and no. I'm not going to move. But since the second number is a positive 1, I'm going to go up 1. So 0 means don't move. Up 1 means my dot is just up 1, and that is the point 0, 1. If I were to graph 3, -7, 3 is positive, so I'm going to move to the right 3. -7 is negative, so I'm going to move down 7. So you start at 0, 0, right 1, 2, 3, and then go down 1, 2, 3, 4, 5, 6, 7. And there's my point right there in blue. Okay? Now I have 7, negative 2. Positive 7 means I go right 7. Negative 2 means I go down 2. So start at 0, 0, 1, 2, 3, 4, 5, 6, 7, down 1, 2, and there's my green point, which is 7, negative 2. Last but not least, I have 7, 0. 7 is positive, so I'm going to go right. That's my first number. And 0 is 0, which means I'm not going to move. So I'm going to start at the origin, 0, 0. I'm going to go right 1, 2, 3, 4, 5, 6, 7. I'm not going to move up or down because it's 0. And that's my purple point, my last point. Okay, so remember, when you graph coordinates on a coordinate plane, positive x means you go right, negative x means you go left, positive y means you go up, negative y means you go down, and any of these are zeros means you don't move at all. Hope this helps. In this problem, I have to list the ordered pairs in a graph. I'm given a bunch of points right here, 6 of them in fact, and I'm to list what those points are. All right, so when you are listing an ordered pair, this is what you're looking for. You're going to start at 0, 0. And if at any point my x value has me moving to the right, it is a positive x value. If I move to the left to get there, that is a negative x value. If I have to move up to get to my point, that is a y value. And in this case, a positive y value is when I move up. And if I have to move down to get there, it is a negative y value. So again, I look for my points. Okay, if I have to move left to get there, it's a negative x. If I have to move right to get there, it's a positive x. If I have to move up to get to a point, it is a positive y. And if I have to move down to get to a point, it's a negative y. All right, so let's just look at each point and go point for point. For all of them, you start at 0, 0. So I'm just going to move my way left to right. I'm going to go U. Okay. So in order to get to this guy right here, I start at 0, 0. And in order to get there, I go left 1, 2, 3, 4, 5, 6, 7. And then I go up 1. Left 7, up 1. So if I were to go left 7, my first point is going to be negative 7. If I were to go up 1, that is a positive y value, so positive 1. Left 7, negative 7, up 1, positive 1. This guy is done. Let's move to u. I start at 0, 0, and in order to get to this point, I go left 1, then down 1, 2, 3. So left means negative, so left 1 is negative 1. Down 3 is also negative, so negative 3. Left 1, negative 1. Down 3, negative 3. This guy is done. Now let's take a look at this one. I'm at 0, 0. In order to get to this point, I move right 1, up 1, 2, 3, 4, 5, 6, 7. Right 1, up 7. Right is positive, so right 1 is positive 1. Up is also positive, so up 7 is positive 7. Right 1, positive 1. Up 7, positive 7. That point is done. Let's take a look at this one right here. In order to get to this point, I start at 0, 0. I go right 1, 2, 3, 4, 5, 6. And then I go up 1. Right 6, up 1. Right 6 is positive 6. Right is positive. Up 1 is also positive. So this point right here is 6, 1. Right 6, up 1, positive 6, positive 1. Let's go down here. If I was going left to right, I guess this one would be next, even though it's tempting to do this one. Doesn't really matter. In order to get to this point right here, I also go right 1, 2, 3, 4, 5, 6. And then I go down 1, 2, 3, 4, 5, 6, 7. Right 6, down 7. Right 6, positive 6. Down 7, negative 7. Last but not least, this point right here, I go right 1, 2, 3, 4, 5, 6, 7, and then I go up 2. Right 7, up 2. Right 7, positive 7, up 2, positive 2, and this is the point 7, 2. So again, you start at 0, 0. You figure out which left-right direction you go, so positive, negative first, and then you go up, down, so positive, negative second. And then once you figure out left, right, up, down, you put those positives, negatives, put it all into a point, and that's how you list an ordered pair. Determine the domain and range from the graph. What I have is I have a graph of 1, 2, 3, 4, 5, 6 points. And in order to find the domain and the range, I have to figure out what the x values are for each point and what the y values are for each point. And what I should do is I should list them out in order. Now, before I do that, let's review what a point looks like. Okay, points are x, y values. The first number of a point is an x. Didn't mean to draw that little mark there. I'm just going to get rid of it. All right, so x is like the first number of the point. Now, in order to get the first number, if I'm looking at the points, if I were to go left to get to that point, that's going to be a negative number. So in this case, if I were to go left 7 to get to that point, it's negative 7. If I were to go right to get to a point, like if I were to go right 2 to get to that point, it's positive. In order for a y to be negative, you go down, and in order for a y to be positive, you go up. So what I'm going to do is I'm going to figure out how far left or how far right I'm going to go to get my domain. So let me write out the word domain. I like to put things in order. So if the first number is going to be in order, I'm going to make sure I go left to right, okay, because it's going to go from least to greatest. So my domain is going to go from me going left 1, 2, 3, 4, 5, 6, 7. So this first point is 1, 2, 3, 4, 5, 6, 7 to the left. And so the first number in my domain is negative 7. The second number in my domain is that guy, left 1, 2, 3, 4, 5, 6. So my second number is negative 6. Here's my third number, 1, 2, 3 to the left, so negative 3. Here's my fourth number, left 1, so negative 1. Now I'm moving to the right. So again, you start at 0, 0 and go right 1, 2. So my fifth number is going to be positive 2. And this last one is going to go right 1, 2, 3, 4, 5. So 5 is going to be the last number in my domain. Negative 7, negative 6, negative 3, negative 1, 2, 5. And while going left to right, you get yourself your domain in order. Now my range is going to be my y values. So it would make sense that the smallest number in my range is going to be the number, or the point rather, from the bottom working my way up. So in order to get a range, I start at 0, 0, and I go down 1, 2 until I hit my first point. So my smallest range is negative 2. You're my second point, so I don't move up or down. I'm already there level with it. And if I don't move, it's 0. My third point from the bottom is that one, and the way I get there is I go up 1. So up 1 is 1. This is my third point, so I'm going to go up 1, 2, 3, 4, 5. So going up 5 gets me that third point. Here's my fourth point. Here's my fifth point. Go up 1, 2, 3, 4, 5, 6. Now I'm lined up with that. And so 6 is my second to last one. And my final one is going to be up 1, 2, 3, 4, 5, 6, 7. And so it's 7. If at any time any of my domains repeat, or if any of my ranges repeat, I'm just going to write that out once. I don't need to say like a range is 0 and 0. I'm just going to write it out once. That didn't happen here. So that's what I do. I determine my domain and my range by going left and right to figure out my domain and down and up to figure out my range. Hope this helps. Is the relation a function? Now, a relation is a set of points. The way you determine if the relation is a function is you make sure that every x value maps to exactly one y value. What does that mean? Well, if I give you a bunch of points, that means the x values cannot repeat. So you're going to look at these, whatever points, 5 points. You're an x value, you're an x value, you're an x value, you're an x value, and you're an x value. If at any point the x values are the same, in this case, -6 and -6 are both x values that are the same. If that is the case, then you do not have a function. So is this a function? No. And the reason why is -6 goes to -7 and -6 goes to 3. In other words, the x values repeat. Therefore, this is not a function. That's it. Which graphs are functions? Now, a relation is a function if the x values map to exactly one y value. What the heck does that mean? Well, when you're given a graph, what that means is it has to pass what's called the vertical line test. The vertical line test says if you take a vertical line, like this one right here, if you're wondering what that line is for, if you pass it through the graph, will the vertical line hit the graph only once no matter what? If it does, it's a function. So what we'll do is we'll take this vertical line test. Now, when I do a vertical line test, I make beeping sounds. And if at any point it freaks out because it's hitting two parts of the graph at the same time, that means it fails the vertical line test and it's not a function. So, beep, 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 beep. Now, at no point did my graph hit the line more than once. So that means it passes the vertical line test, and yes, this is a function. Now let's do it again. Okay, let's do it again. You see, nothing, 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 nothing. Beep, 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 beep. Now, hold on, let me hit the mute button. Beep. Now, if I were to put my line over here, it would be beep, 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 beeping because this line is hitting the graph at 1 and 2 spots. So this fails the vertical line test, which means it's not a function. All right, so let's move this over. Let's move this over. Let's get rid of this line and pretend that I didn't do it. And let's hit the unmute button. All right, now let's do this one more time. I'm going to take my vertical line and pass it through this mess of an equation and see if it hits the blue line more than once. Beep, 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 beep. Interesting. At no point did my line hit the blue graph more than once. It looks like it's awful, but that doesn't matter if it looks awful. It doesn't hit more than once. So is this a function? Yes, because it passes the vertical line test. So vertical line test means you take a vertical line, you pass it through your graph, and if at any point it hits it more than once, like it did here, me pretending to draw a vertical line, then no. If at any point it never hits a vertical line more than once, then yes, it is a function. That's how it's done. Okay, this problem is asking me to evaluate a function. Now, this guy right there is f of x. F of x is the same as y. Don't freak out about it. This is not f times x. So what this is asking me to do is find f of 0. What that means is I'm going to write out f of 0, and I'm going to replace every x with parentheses 0. So this is going to be 4 parentheses 0 plus 2, and now this becomes a PEMDAS problem. Okay, f of 0 means replace every x with parentheses 0. So you do the little bit of math according to PEMDAS. You do multiplication first. 4 times 0 is 0. And 0 plus 2 is 2. So at the end of the day, we could say f of 0 equals 2. And what I did is I replaced every x with parentheses 0, did PEMDAS, got 2, dunzo funzo. Evaluate f of x equals x plus 6 if I'm given f of 3.8. Now, what is f of x? F of x is the same as y. And when it asks me to find f of 3.8, that means replace every x with 3.8. It used to be f of x. Now it's f of 3.8, so x is now 3.8. So I'm going to write this out. If I chose a pen, that would be better, as f of 3.8 equals, and again, I'm going to replace every x that I find with parentheses 3.8. So I'm given 3.8 plus 6. Now, in this case, the parentheses aren't necessary. Does that mean I should never use parentheses? No, I'm always going to use parentheses when I substitute a number in for a variable. It's just I don't need it here. 3.8 plus 6 is 9.8. So at the end of the day, I could say that f of 3.8 is equal to 9.8. And I'm done. Evaluate f of x equals negative 3 times the absolute value of x minus 4 and find f of 3. Now this is f of x. F of x is the same as y. What does it mean to find f of 3? That means I'm going to replace every x with a parentheses 3. So I'm going to write out f of 3 equals, and I'm going to write out this guy and replace that one x with parentheses 3. So negative 3 times the absolute value of parentheses 3 minus 4, close the absolute value. Now this is a PEMDAS problem. And the PEMDAS says that we always do everything inside the parentheses. Now, you might be looking at this and saying, well, the only parentheses I have right there is 3, but there's nothing inside it. Correct. But included in the parentheses are absolute value symbols. So what we're going to do is do everything inside the absolute value symbol. So inside the absolute value symbol, I have 3 in parentheses minus 4. These parentheses, not necessary. So 3 minus 4 is negative 1. Okay, so I now have the absolute value of negative 1, and negative 3 is lingering on the outside. Now I'm going to use my absolute value. Absolute value turns any number positive. So it used to be negative 1, now it's positive 1. So this becomes negative 3 times positive 1. Negative 3 times positive 1 is negative 3. So after all of this, f of 3, when doing all the PEMDAS math, became negative 3. All right, so evaluating a function means taking that number, plugging it into x, and not forgetting the parentheses, even though in this case the parentheses wasn't that necessary. More often than not, it is necessary. Make sure you use it. And I had to do absolute value stuff first, and then I could multiply, and I ended up with negative 3. So f of 3 is negative 3, the end. Evaluate f of x equals x squared plus 2x minus 4, and my job is to find out when I'm given f of negative 1. F of x is the same as y, but it's written as function notation. F of negative 1 means take every x value and replace it with parentheses negative 1. So f of negative 1 has me taking both of these x's and replacing both of these x's with parentheses negative 1. So right away, x becomes parentheses negative 1 squared plus 2 times another x parentheses negative 1 minus 4. Now this becomes a PEMDAS problem. PEMDAS says, can I do anything inside parentheses first? No. That's a parentheses, but there's nothing inside them but negative 1s. Then I do exponents. This is an exponent. I am squaring parentheses negative 1. Negative 1 in parentheses squared means negative 1 times negative 1, which is positive 1, plus 2 times negative 1 minus 4. The exponents are taken care of. PEMDAS says I do multiplication, division, left to right. Here's a multiplication problem. So 2 times negative 1 becomes negative 2. 2 times negative 1 becomes negative 2. So I have 1 minus 2 minus 4. And now I'm left with addition and subtraction left to right. Okay, 1 minus 2 is negative 1. 1 minus 2 is negative 1. and -1 minus 4 is -5. So when I have f of -1, that means I plug in -1, making sure I have my parentheses, and after I do a little bit of PEMDAS, I end up with -5. And that's my answer. Graph the function for the given domain if f of x equals -x plus 4, and you have a domain of -4, -3, regular 2, regular 4, and regular 6. So we are going to make a table. And I'm going to have it be a three-part table. Okay. Part number one, I have my domain, which is my x values. So let me quick write those out. -4, -3, 2, 4, and 6. What I'm going to write out here in this second part is what f of x equals. Now it's going to equal -x plus 4. So what I'm going to do for each of these numbers individually is I'm going to replace x with parentheses that number. So for -4, I can write out something like f of -4 equals negative parentheses -4 plus 4. -4 is 4 plus 4, and that's going to give you 8. So we'll write that there. We'll deal with that in the third column in a second. Let's do it again. F of -3 equals negative parentheses -3 plus 4. So the double negative becomes positive. 3 plus 4 is 7. Let's do it again. F of 2 equals negative parentheses 2 plus 4. -2 plus 4 is 2. So we'll write that out, and we'll write that out. Okay, f of 4 is negative parentheses 4 plus 4. So negative parentheses 4 is -4, and -4 plus 4 is 0. And last but not least, we have ourselves 6. So f of 6 is going to equal negative parentheses 6 plus 4, which is -6 plus 4, and -6 plus 4 is -2. Now, what this gives us is ordered pairs. And even though it's f of x, remember, f of x is the same exact thing as y. So I'm going to treat this as a point that looks like f of x, okay, or y. So technically, you write out the point like this, but don't overthink it. It's just xy, all right? Since we plugged in -4, since our x was -4, and after we did that, we got 8, we get the ordered pair -4, 8. When I plugged in -3, I got 7, so -3, 7. When I plugged in 2, I got 2, so 2, 2. It's like we're at a ballet recital. When I plugged in 4, I got 0, so 4, 0. And when I plugged in 6, I got -2, so 6, -2. Now, let me use different colors to graph each of these points, each of these ordered pairs. -4, 8 means I travel from 0, 0, left 1, 2, 3, 4, up 1, 2, 3, 4, 5, 6, 7, 8. And there is my point, -4, 8. When I want to do -3, 7, I travel from 0, 0, left 1, 2, 3, up 1, 2, 3, 4, 5, 6, 7. Put a nice little dot there, and that's -3, 7. 2, 2 has me going from 0, 0 and going right 1, 2, up 1, 2. Put a dot there, and there's my 2, 2. 4, 0 has me going from 0, 0 and going right 1, 2, 3, 4. And then the 0 tells me don't move. And then last but not least, we have 6. 6, -2 has me going right 1, 2, 3, 4, 5, 6, down 1, 2. And there you have it. All right, so what this looks like is a bunch of dots that if we were to connect the dots, we would get a straight line. But I'm not going to connect the dots because that's not what they want me to do. They just want me to list these 5 points based off the domain, -4, -3, 2, 4, and 6. Hope this helps. Graph the function for the given domain. So I have f of x That equals 3 times the absolute value of x minus 5. And the domain I'm going to use is going to be 3, 4, 5, 6, and 7 in that order. So let's make ourselves a little table. Okay, and it's going to be a 3-part table. Let me give myself plenty of space. In the first column, I'm going to have the x values, which is my domain. And my x values are going to be 3, 4, 5, 6, and 7. In the middle, what I'm going to do is I'm going to type out, or actually calculate, what f of x is given the x value that I have. Okay, so I have 3 times the absolute value of x minus 5. Now, whenever you plug something in, right, so when I want to find out what f of 3 is, I'm going to replace x with parentheses 3. So I have 3 times the absolute value of parentheses 3 minus 5, close the absolute value. Now, inside the absolute value, I have 3 minus 5, and 3 minus 5 is negative 2. This follows PEMDAS rules now. So you do everything inside the parentheses, or in this case, inside the grouping symbol, the absolute value. So I do 3 minus 5 first. So 3 times the absolute value of 3 minus 5 is negative 2. The absolute value of negative 2 is regular 2, so 3 times 2. Let me scooch over this line because I'm going to need the space. And that's going to end up giving me 6. Okay, after all that, 6. Let's do it again with 4. F of 4 is going to equal 3 times the absolute value of parentheses 4 minus 5. Close the absolute value. Inside the absolute value, you have 4 minus 5, which is negative 1. So 3 times negative 1. The absolute value of negative 1 is regular 1, so 3 times 1 is 3. Let's do it again with 5. F of 5 is going to equal 3 times the absolute value of parentheses 5 minus 5, close the absolute value. Inside the absolute value, I have 5 minus 5, which is 0. The absolute value of 0 is 0, and 3 times 0 is 0. Okay, easy peasy. Let's try for 6. F of 6 is going to equal 3 times the absolute value of parentheses 6 minus 5, close the absolute value. 6 minus 5 inside the absolute value is regular 1. And 3 times regular 1, the absolute value of 1 is regular 1. I don't know if I said that. 3 times regular 1 is 3. Remember, absolute value always makes something that's positive or negative, it makes it positive. So the absolute value of 1 is 1. And so we can see, those numbers are going back up again. That's supposed to happen. F of 7 is going to equal 3 times the absolute value of parentheses 7 minus 5. Close the absolute value. Inside the absolute value, I have 7 minus 5, which is 2. So 3 times the absolute value of 2. The absolute value of positive 2 stays positive 2. So 3 times 2 is 6. Now back over here in this chart where I thought I had enough space, that's going to be my x, y values, or my x, f of x values. Okay, so when I graph them, I have points. For example, I have 3, 6, which is the point 3, 6. I plugged in 3, I got out 6. That gives me the ordered pair 3, 6. I plugged in 4, I got out 3, 4, 3. I plugged in 5, I got out 0, 5, 0. I plugged in 6, I got out 3, 6, 3. I plugged in 7, I got out 6, 7, 6. Now let's graph these 5 points on this coordinate plane. Okay, so whenever you're graphing points on a coordinate plane, you start out at 0, 0 and figure out the directions you go. Everything here is positive except for 0, so we're either going to the right and then up. So this is going to be right, 3, 6 is going to be right 1, 2, 3, up 1, 2, 3, 4, 5, 6. So fly like a 3, 6. Remember that song? It was like 12 years old, if not older. This is 4, 3. Go right 1, 2, 3, 4. Go up 1, 2, 3. That's the coordinate 4, 3. The coordinate 5, 0 has me going right 1, 2, 3, 4, 5. Don't move because 0 means don't move, and that's my point. 6, 3 is going to have me go to 0, 0, and then go right 1, 2, 3, 4, 5, 6, up 1, 2, 3, and then I have my dot right there. Last but not least, 7, 6 is going to have me start at 0, 0, go right 1, 2, 3, 4, 5, 6, 7, up 1, 2, 3, 4, 5, 6. And that's that. Now, if you're looking at this and wondering, why is it like a V shape? Why isn't it a straight line? If you watch all my videos in order, you'll notice that the last one was a straight line if I were to connect the dots. Well, absolute values are going to have those behaviors. They make V shapes because things are going to stay positive for the most part. That's what I like to do with my attitude, and that's what this problem does right here. Stay positive. And you know what, kids? You stay positive too, because that's what you should do in life. Well, I hope this helps. Thanks for watching. Graph the function f of x equals negative 2x minus 1. Now, if you watch my previous videos, you'll notice that in the last two videos, I had a domain. I gave you specific x values that I wanted you to plug in. Not anymore, but I'm going to treat this in a very similar way. I'm going to make myself a nice little 3-column table like so. I'm going to pick x values and then plug them into f of x equals negative 2x minus 1. When I do that, I'm going to get f of x values for me to graph. And then this problem is different because I'm going to have one more step. So what I said before is I'm going to pick x values. This is, well, never mind. I was going to say something that you're supposed to not know yet, so I won't say anything. I am going to choose negative 2, negative 1, 0, 1, 2. This is the very beginning of graphing functions. So like really, you don't have to be super worried about what numbers to choose when you choose your x values. These are the ones I chose because they're centered nicely around my coordinate plane. So I'm going to say f of negative 2 equals. Now what I do when I plug in negative 2 is I replace x with parentheses negative 2 like that, and then I do whatever math is necessary. Negative 2 times negative 2 is positive 4. Positive 4 minus 1 is 3. Let's do it again. F of negative 1 has me replacing x with parentheses negative 1. Negative 2 times negative 1 is positive 2, and 2 minus 1 is 1. Let's do it again. F of 0 equals negative 2, replace the x with parentheses 0. PEMDAS says negative 2 times 0 is 0, and 0 minus 1 is negative 1. Let's do it again. F of 1 equals negative 2 times 1. Negative 2 times 1 minus 1 is going to be negative 2 times 1 is negative 2. Negative 2 minus 1 is negative 3. And then last but not least, I have f of 2, which has me doing negative 2 times parentheses 2 minus 1. Negative 2 times 2 is negative 4, and negative 4 minus 1 is negative 5. So now that I have these, I can build together these coordinates. I can make my points. When I plugged in negative 2, I got out 3. When I plugged in negative 1, I got out 1. When I plugged in 0, I got out negative 1. When I plugged in 1, I got out negative 3. And when I plugged in 2, I got out negative 5. All right, so I have 5 points that I'm going to graph. And again, I chose 5 x values. If you're wondering, well, could I choose 3? Could I choose 2? Could I choose 1? Listen, you'll see what graph this is going to look like. When you first start out graphing functions, you're going to want to pick about 5 points just to be on the safe side. And that's why I chose 5 points, because I'm a math teacher and that's what I always do. Okay, let me graph this first point, negative 2, 3. Negative 2, 3 has me going from 0, 0, left 2, up 3. So left 1, 2, up 1, 2, 3, put a dot right there. graphing the point negative 1, 1 has me going left 1, up 1, left 1, up 1, put a dot right there. 0, negative 1 has me not moving and going down 1. So start at 0, 0, don't move, go down 1. Now I have 1, negative 3. So this has me going right 1, down 3. So start at 0, 0, right 1, down 1, 2, 3, put a dot there. And last but not least, I have 2, negative 5. So start at 0, 0, right 2, down 1, 2, 3, 4, 5. Now you will see that what I got are a bunch of dots in a straight line. Am I done? No. And the reason why I'm not done is because if you're not given the domain, your job is to connect these dots. Now, I am absolutely terrible at connecting these dots, so you will see some funny looking shapes pop up. I'm going to get a line because, again, I'm awful at this. So let me get a line. And what we're going to do is we're going to take this line and we're going to use this line to connect the dots. Okay, so connect the dots. And the last thing that we want to do, by the way, let me show you the wrong way of doing it. There. The wrong way of doing it is only connecting the dots that you have. If you're like, well, why not? Those are the dots. Those are the dots that you chose. Exactly. Those are the dots I chose. This is following a pattern. If I were to pick 3, there's going to be another dot right there. If I were to pick negative 3, there's going to be another dot right there. So when we graph this and we create our line, we make sure that that line covers everything. So what you would want to do if you're using pencil and paper is you would want to use like a ruler and make sure you connect the dots and show that line going throughout the entirety of the coordinate plane. Since this is a line, I'm going to make sure that I put arrowheads at the end of it to show that technically if this coordinate plane was bigger, the line would go even further than what we have. So that's what graphing a function looks like. You pick your points, you plug them in, you get your dots, you graph your dots, you connect the dots, and you put arrows depending on what your graph looks like. Wasn't that fun? It was fun. Thanks for watching. Graph the function. Now, if you watch all my videos in order, you saw a very similar video before this one, and we're going to treat it the exact same way. Now, before we were graphing functions, we were given a domain. We were given the x values to use. Now I'm not given x values, so I have to create my own x values. So I'm going to make myself a 3-column chart. In the first column, I'm going to pick a bunch of x values. In the second column, I'm going to say f of x equals 4x minus 4, and that's going to show me showing my work. And in the third column, I'm going to have the coordinates that I'm supposed to get after plugging stuff in. Okay. Now, I pick my x values. I pick them. Does it matter which x values to pick? No. Now, the x values that I pick, I have a feeling aren't going to be good ones, but that's okay. It's the thought that counts. In my last video, I picked -2, -1, 0, 1, and 2, and I'm going to do the exact same here. If while doing this, you realize that the points you picked are bad, then pick different points or pick more points. And if you're wondering, well, what do you mean bad points? Oh, you'll see, friends. You'll see. Now that I picked my x values, I'm going to plug them into f of x. So f of -2 means I'm going to write out 4x minus 4, but replace x with parentheses -2. So 4 times parentheses -2 minus 4 is following PEMDAS. 4 times -2 is -8 minus 4, and -8 minus 4 is -12. Now I'm going to step outside the box compared to what I did before. All right, now usually I do all the math, and then I put my points in. This guy says if I plug in -2, I get out -12. Great. There's a problem though. This graph doesn't go out to -12. So picking -2 was a bad choice. Does that mean the problem's over and I give up? No. That means I keep going and hopefully -1 isn't a bad choice, and then I can get some friendlier points that I can graph. Right now, trying to graph -2, 12 is just not going to look right for me. So let's just keep going and see what happens. All right. f of -1, I'm plugging in -1 for every x, so 4 times parentheses -1 minus 4. 4 times parentheses -1 is -4. -4 minus 4 is -8. So now when I plug in -1, I get out -8. Now I do have a point that I can graph. So hopefully we're on the right track that we were once off of our graph and now we're back on it. So let's keep going and see if the numbers are friendly enough. F of 0 means replace every x with parentheses 0. So 4 times 0 minus 4. PEMDAS says 4 times 0 is 0. 0 minus 4 is -4. When I plugged in 0, I got out -4, easily graphable. F of 1. 4 times parentheses 1 minus 4 is 4 times 1. 4 minus 4 is 0. 4 times 1 is 4. 4 minus 4 is 0. Bada bing. That gives me the point 1, 0. 2. F of 2 equals 4 times 2 minus 4. 8 is 4 times 2. 8 minus 4 is 4. So when I plug in 2, I got 4. When I plug in 2, I got 4. So even though one of these didn't work, 4 others did. And that's why I choose 5 points every single time that I've done this so far, is because you may have one that won't work. That's okay. We just won't graph it. Am I wrong? No, we just won't graph it because we can't. So I'm going to graph -1, -8, because that will barely fit. This has me starting out at 0, 0, go left 1, go down 8, -1, -8. 0, -4 has me starting out at 0, 0. Don't move, go down 4. 1, let me put a blue dot there so we know what's what. 1, 0 has me starting at 0, 0, going right 1, don't move. So that's 1, 0, right 1, don't move. And last but not least, we have 2, 4. And if you're wondering, what's a 2, 4? For chewing. You go right 2, you go up 4, you go right 2, you go up 4, and there you have it. Now, when you graph a function, you're going to get whatever dots based on the points that you chose initially. I got 4 dots. So what am I done? Or do I just like walk away and say I'm done the problem? No. Here's the thing. These are the dots I got because these are the x's I chose. If I were to choose 3, I would be able to squeeze another dot right there at 3, 8. But I didn't. So what we're going to do to graph this is we're supposed to assume that all of these points are represented. So I'm pulling up a line. That's the thing you're seeing on the left side. And we're going to connect these dots. Again, when you graph a function, right, you are going to take all of the dots and connect them, the denots. Now, this is wrong. Me connecting only the dots that I have is wrong. And if you're wondering, like, why? Those are the 4 points you got. Yes, but again, those are the 4 points I got because those are the 4 points I chose. If I chose 3, there'd be another dot up there. So we have to include all possible values. So this line is going to keep going forever and ever and ever. So make sure your line covers the entire coordinate plane. If you're doing this on paper, make sure you use a ruler, and that'll help you figure that out too. I'm going to put arrowheads because this says, look, if this coordinate plane was even bigger than it already is, I'd have dots way up here and dots way down there. But that's how you graph a function. You pick whatever x values you need to do or you want. Okay, you choose what your f of x is based off of the x's that you do. You do whatever math. That gives you points. Oh, well, none of them or one of them didn't work. Then one of them didn't work, but 4 of them did. And 4 points is more than enough to make a nice straight line. So there you have it. That's how you graph a function. Thanks for watching. Graph the function f of x equals 2/3 x minus 5. Now, if you watch all of my videos, and I pray that you do, and if you watch this in order, you would have seen me do 2 problems very, very, very similar to this before this one right here. And in both cases, what I did is I made myself a nice 3-column table. Okay, I called the first column my x values. The middle column is going to be f of x equals the equation that I have, the function that I have, and my third column is going to be the points that I get after I choose my x's, plug stuff in, and get a value. This is where it differs from the last two videos. The last two videos, the number in front of x was not a fraction. Now the number in front of x is a fraction. So what I did in the last two videos is I just chose a bunch of x's based off of whatever I felt like using. I chose -2, -1, 0, 1, and 2. I did that for both of those videos. I'm not going to do that here. Why? Because if I were to choose a number like -1, I'm going to get another fraction, and -5 is not going to be pretty, and I really do not want to graph an equation where I have fractions as dots. I don't want to do it. So here's a trick. Here's a trick. When you choose your x values to plug in, if you have a fraction, use multiples of 3. What's multiples of 3? 3, 6, 9. Darn girl fine. Sock it to me. One more time, get low. Remember that song? Anyway, choose those. I'm not going to choose exactly those because I like to do some negatives. So what I'm going to choose is -6, -3, 0, 3, and 6. And by choosing multiples of 3, I'm not going to have to deal with fractions. So step number 2 is I'm going to use these numbers right here and plug them in. By the way, I wouldn't want to plug these numbers in anyway because those numbers aren't even on the coordinate plane. So, yeah. All right. Now let's plug in these numbers. F of -6. When you plug in a number for x, you replace the x with parentheses that number. So 2/3 times parentheses -6 minus 5. Okay, so 2/3 of -6 is -4. -4 minus 5 is -9. You might be thinking, whoa. You just said how you're not going to use 9 because that number is too big. And look, you got -9. So how in the world are you going to get the point -6, -9 on the graph? I won't. Now, I can kind of force it, but I won't. Sometimes when you do problems like these, you're going to realize that one of the points that you chose or one of the x values that you chose is just simply not going to work. And this is going to be one of them. Okay, so let's keep going. F of -3 means I'm going to replace every x value with -3 in parentheses. 2/3 of -3 is -2. So I have -2 minus 5 is going to equal -7. Now I can graph the point -3, -7. That's fine. And now it seems like we're going to be on the good track. If I plug in 0, that's f of 0 equals 2/3 times 0 minus 5. 2/3 of 0 is 0. 0 minus 5 is -5. And that gives me 0, -5. If I plug in 3, that's f of 3. 2/3 of 3 minus 5. 2/3 of 3 is 2. 2 minus 5 is -3. And that gives me the point 3, -3. If I plug in 6, I get 2/3 of 6. Oh, minus 5. Oh boy. After all that work, having to make a mistake there would have been a bad idea. Minus 5. 2/3 of 6 is 4. 4 minus 5 is -1. And that gives me the point 6, -1. So now I have 4 points that I can graph. The first point didn't work out, no big deal. If I wanted to graph -3, -7, I start at 0, 0. -3 is left, -7 is down. So left 1, 2, 3, down 1, 2, 3, 4, 5, 6, 7. There's my point. 0, -5. So let me choose a different color. 0 means don't move. -5 means down 5. So 0 means don't move. Down 1, 2, 3, 4, 5. Put a dot there. 3, -3 means start at 0, 0. Go right 3, down 3. Right 1, 2, 3, down 1, 2, 3. Put a dot there. And last but not least, we have 6, -1. So that's right 6 down 1, right 1, 2, 3, 4, 5, 6 down 1. There you have it. Now, what I have are 4 dots that appear to be in a straight line. If you're graphing a function, you are connecting those dots. So let me go over here, pull up a line. That's what you're seeing pop up on the left. And I'm going to take that line and connect the dots. Now, again, if you watch all my videos, and I pray that you do, you will realize that if I were to connect the dots and leave it like that, you're wrong. Because these are the points that I got based off of the x's that I chose. If I were to only choose like -3, 0, and 3, should I just connect these 3 dots? No. What you would do is if you had a piece of paper, you would take a ruler and you would just kind of keep that line going and keep the pattern going like that on both ends, and you would try to have your line, you would try to have your line cover the entire coordinate plane like I just did. You draw your arrowheads because by drawing arrowheads, you are saying this line goes on forever. So if this coordinate plane was a little bit bigger and I could fit -6, -9, it would go through that dot right there if the coordinate plane was bigger. All right, so that's how you graph a function. You pick out x values, you graph the points that do work out, you connect the dots, cover the whole thing. Dunzo, funzo, functions complete.